multiplying and dividing rational expressions. So we already looked at simplifying them. And if you remember, a rational expression, it's basically a fraction, but generally they're not just numbers. They're an algebraic expression over an algebraic expression. But we do need to think about how do we multiply and divide fractions. And the reason is it works exactly the same when it's rational expressions. So really there's nothing new for me to teach you because you guys already know how to do this. But remember what I said about these ones. We want to, when we have something like 16 over 15 times 3 over 12, simplify first. And one of the main reasons that I'm going to simplify first is because if I try to do 15 times 12 in my head, I could do it, but it's not just there, right? It's not one that I've memorized. Maybe you guys do. Who knows what 15 times 12 is? A big number. A big number, right. So I don't want to have to do that in my head. And if I reduce it, I probably can do it in my head. So let's look at two of them that have a common factor. It has to be a numerator and a denominator. What do you see? 3 and 15 can both be divided by 3. That turns into a 1, and that turns into a 5. 16 and 12, what's their common factor? 4. Divide them both by 4. This becomes a 4, and this becomes a 3. And then we can say this is equal to, on the top, 4 times 1, which is easier to do than 16 times 3, right? And instead of 15 times 12, now we're doing 5 times 3, which is 15. And probably I won't need to reduce at the end because I already did it. The only time really I'm going to have to reduce at the end is if I missed something earlier. So we're just switching the order that we're doing the reducing, which is probably not what you originally learned when you learned how to multiply fractions. You multiplied and then reduced. But this just makes it easier and applies more to what we're going to be doing with rational expressions. Then for the dividing, 1/2 divided by 6 over 5. Remember, we need to do 1/2 multiplied by 5 over 6. Anything that can be reduced? No. So we'll just do 1 times 5 is 5. 2 times 6 is 12. So if you can remember those basic things about how to reduce and how to multiply numerator by numerator, denominator by denominator, what to do with division, then you're all set for the next thing, which is when we start looking at algebraic things like this. 12m squared f over 5cf times 15c over 4m. We're going to multiply numerator by numerator and denominator by denominator. But it will be a lot simpler if we do the reducing first. So I want you to find one factor that's in the numerator, any numerator, so first or second numerator, and first or second denominator so that we can simplify. I heard somebody say F. There's an F in this numerator and this denominator. Those are gone. We don't have to worry about F's anymore. What else? 5 and 15. Well, I'm going to look at the C separately from the numbers because sometimes the common factor won't be in the number and the letter. But C is in both of them, and also 5. This divides by 5 and changes to a 1. This divides by 5 and changes to a 3. Anything else? M and 4. M is here, and it's also up here. I'm just going to cross out the 2, because now it's just an M, right, when we divide by M. 12 and 4 have a common factor of 4, so that turns to a 1, and that turns to a 3. The only problem here is that it gets kind of messy, and it's hard to see what's left. I'm just going to write it out here what we have. 3m over 1 times, 3 over 1. Is that all we have left? So this becomes 9m. Non-permissible values, C, F, and M cannot equal 0. You can't see that. Any time that you're working with rational expressions, you should be including the non-permissible values. This is another one of multiplying rational expressions. They look a little more complicated. But what do you think we need to do? factor, right. So the first one factors to a minus 4 times a plus 3 on the top, and the bottom is a difference of squares. So that's a plus 3, a minus 3. And the second one, the numerator factors to a minus 3 and a minus 1, and the denominator, you just remove a common factor from a squared minus 4a. And the common factor is a, so it becomes a times a minus 4. Then we need to look for common factors. So a factor that's in the numerator and also in the denominator. A minus 3, yeah, it's in the first denominator, the second numerator. What else? A plus 3 is in the first numerator and first denominator. A minus 4, first numerator, second denominator. That's it, right? So that leaves us with a minus 1 over a. Non-permissible values. A cannot equal positive or negative 3, 4, and 0. We need to look at both denominators. So the denominator of the first one, a plus 3, a minus 3, that gives you a positive and negative 3. And the second one, a times a minus 4, that gives you the 0 and the 4. One last question to do. It's a division question. So the first step is actually... Okay, so the question is, do we factor first or flip it first? I would take the reciprocal first. The reason is, if I factor first, I might forget to take the reciprocal. So when it's division, first thing I'm always going to do is flip it over. So this will be x squared minus 6x minus 7 over x squared minus 49, right? First one doesn't change, but then change it to multiplied by x squared plus 7x over x squared plus 8x plus 7. So you factor this, and then look for common factors. So in the numerator of the first one and the denominator of the first one, there's an x minus 7. So we'll cancel those out. X plus 1 is in the first numerator and the second denominator. X plus 7 is a common factor. It's in the first and second denominator and the second numerator. What do I do with that?
You keep one, right?
Keep 1. Yeah, cross out 2 and keep 1. So get rid of one numerator and one denominator of an x plus 7 and keep the other x plus 7. So what we end up with for an answer is x over x plus 7. And x cannot equal
7 and 0.
positive and negative 7, negative 1 and
0.
0. Why 0? We don't usually look at the numerators for non-permissible values, right? But that x on its own that gives you the 0 is in the numerator. Why are we including it here?
Because you can't have 0 out of 7.
Because you can't what?
Have 0 out of x plus 7. Like, that's just nothing. Or 0 out of 0 plus 7 is...
What do you think?
Or 0.
So the reason that we include the 0 as a non-permissible value, even though it comes from the numerator, is basically, you can think of it like this. That numerator actually is a denominator, because up here, we're dividing by it. So you have to, when you're dividing, don't just look at the two denominators to come up with the non-permissible values. Look at the two denominators and the second numerator once you've changed it to multiplication. The only place you don't need to look when it's division is this first numerator.